Continuing my videos on the class practice, here is number 64. Now this is the same circuit as number 63, except now I don't have my battery potential, and I want to solve for the potential across that 2 ohm resistor as well. So to approach this, the first thing we do is what I've been doing in class. Let's write the equation for the loops. So first I'm going to go around this blue loop right here. And what that is, I start with my battery potential, and now instead of adding, I'm just going to subtract, because I know that's what we're really doing. Anything other than the battery takes away from the voltage, so I'm just going to subtract. Now, in the blue loop, I go through resistor 3, so the voltage drop of 3 is subtracted, and then I don't have anything else to go through, so that's equal to 0. And so what this means is my battery potential is equal to the potential drop across 3. And what do you know? I can actually solve for that. If delta V equals current times resistance, the current in that branch is 4 amps, and the resistance is 3, so the potential drop is just 12. So I know my battery potential is 12 volts. So what then do I do with that? Well, if we think back to the last problem, we found that our equivalent resistance for this circuit is 2 ohms. Now what I can do is I can say, okay, I know I have 12 volts supplied by the battery. My total current is just going to be 12 divided by my total resistance, and so I get that the total current for this circuit is 6 amps. So there's 6 amps coming out of that battery. So now if I know that there's 6 amps coming in to this junction right here, and 4 comes out through the 3 ohm resistor, all that's left to go to this branch is 2 amps. And so I know that since these are in series, 2 amps goes through each of them. So if 2 amps is going through that 2 ohm resistor, and V2 equals I2 times R2, then the voltage drop across 2 is just 2 amps times 2 ohms, and that is negative 4 volts, and it's negative because it's a resistor, so it drops the voltage. And so that's it for this one.